Hello and welcome to graphing absolute value functions. So we just spent time where we were solving absolute value equations and absolute value inequalities. Now we're going to go into graphing these absolute value functions. And notice in these functions we have two letters. We have the x and the y. So it's written similar to something like y equals mx plus b, where we're talking about y-intercepts and slopes. So we're going to do a couple of these problems and we're going to make some t-charts, and then we're going to make some educated guesses, and we're going to come up with a rule that happens. Now all of these you can always solve by making a t-chart that we have over here. So over here we have some numbers that we're going to plug into this absolute value. So the first one that they want us to plug in is a -2. So if we put a -2 in here, what is the absolute value of -2? Well, the absolute value of -2 is 2, so y equals 2. So we have the ordered pair -2, 2. Now I can go over here and graph that and go -2. Remember, that's in the direction of x, so I go left 2 and then up 2, so I have this point right here. All right, so now the next number I'm going to put in is a -1. So when we put in a -1, the absolute value of a -1 is 1. So we end up with y equals -1. Oops, is +1. Sorry about that. Is a +1. So we end up with the 1. So we have the ordered pair -1, 1. So -1, 1 would be that ordered pair right there. All right, the next number that they want us to put in is a 0. So y equals the absolute value of 0. What is the absolute value of 0? 0. So we have this ordered pair 0, 0. And remember, we talked about that being the origin. So we're at 0, 0. The next number that they want us to put in is this 1. So y equals the absolute value of 1. Well, remember, the absolute value of 1 is 1 because it's one number away from 0. So we put in the ordered pair and we have 1, 1. All right, so go over 1, up 1. Well, this is not a straight line what we were having before, which makes sense because these have absolute values in them. So it's going to look exactly like our linear equations did. All right, and the last number that we have to put in here is a 2. So we have y equals the absolute value of 2. The absolute value of 2 is 2, so we have the ordered pair 2, 2. And when we graph that, we have 2, 2. Now, we could keep going and put in a -3 and a +3 and a -4 and a +4, but we can see that there is a pattern forming here. And it's going to look like this. So when we graph an absolute value, what we end up with is a shape. It's like two different lines starting here at this point, which is called the vertex of the absolute value. So this vertex and this vertex in this case happens to be 0, 0. And if we look, you know how I mentioned that we had this m in front, which stands for slope? So when we write an equation, y equals 3x plus 7, we would say that this slope is 3. That number in front of the x represents the slope. Well, if we go back and look at our equation here, what number do we have in front of x? Well, we don't. And remember, mathematicians say that that's a 1. So in this case, this slope or slant would be a 1. So let's look. If we start here at this vertex, do we go up 1 over 1, up 1 over 1, up 1 over 1? Because of the absolute value, that pattern also happens on the left side, and that's why we end up with the V. There's a mirror effect, and there's something called the axis of symmetry. So if we were to fold right on this axis, those two lines would lay on top of each other. All right, let's try another one here. So, it looks like we have the absolute value of x, but they put a number on the outside this time. So let's see what happens when we put that number on the outside. So this time I'm going to put in a -2. So the absolute value of negative 2 is 2, and 2 minus 1 is 1. So we end up with this being a 1, so we end up with the ordered pair, negative 2, comma, 1. Okay, I'm going to go left 2, up 1. Left 2, up 1. All right, let's try the next one. So now they want us to put in a negative 1. So y equals the absolute value of negative 1 minus 1. Well, the absolute value of negative 1 is 1. So now I have 1 minus 1. So y is 0. So I have this ordered pair, negative 1, comma, 0. So negative 1, and then we don't go up or down, and we are at 0. All right, next number they want us to put in is a 0. So y equals, and the absolute value of 0 is 0, and 0 minus 1 is a negative 1. All right, so we have the ordered pairs 0, comma, negative 1. So we do not go left or right, but we go down 1. All right, the next ordered pair that they want us to plug in, they want us to plug in a 1. So the absolute value of 1 minus 1. Well, the absolute value of 1 is 1, and 1 minus 1 is 0. So we end up with the ordered pair 1, comma, 0. All right, go over 1, but now we're not going to go up or down, so it's 1, 0. All right, and our last number here that they want us to plug in is a 2. So the absolute value of 2 is 2, and 2 minus 1 is 1. So we get the ordered pair 2, comma, 1. All right, over 2, up 1. Well, look at that. We ended up with a V, and if you look at this V, it's opening up. And if we look at this number in front of x, we don't have a number there, so it's a 1. And look at, we went up 1 over 1, up 1 over 1. So it's not over, it's not being opened or closed anymore. It's a natural, normal, standard parent width is what we call this. But let's look at this vertex. According to the last one, that last vertex was right here at 0, 0. So if that vertex was at 0, 0, look at this one. It went down 1. Now look at that original equation. What number do we have on this outside here is a negative 1. And what would a negative 1? Notice this is on the outside of the absolute value. And we have that negative 1. And look at this vertex. It went down 1. Everything else stayed the same. It's opening the same width. It's still up 1 over 1. It's still opening up, but the only thing is that vertex went down 1. All right, let's try another one. Oh, we got a number on the outside and it's a plus 1. So some of you might be guessing that this shape is still going to be a V because of those absolute values. Some of you might be saying, oh, well, there's a 1 in front, so I think it's going to do the same thing, and up 1 over 1, so the width's going to be the same. But now, how is this plus 1 going to affect that vertex? What is going to happen in this case? And some of you might be guessing. You might be saying right 1, you might be saying left 1, you could be saying up 1. I hope you're not saying down 1, because what made it go down 1 in our last sample here was when we had a minus 1 out here. And we don't have a minus 1, we have a plus 1. So when that was a minus 1, it went down. Well, let's see what's going to happen. So let's plug in, and this first one, they want a negative 2. So the absolute value of negative 2 is 2. 2 plus 1 is 3. So we end up with the ordered pair negative 2, 3. Negative 2, 3. All right, the next number that they want us to plug in is a negative 1. So y equals the absolute value of a negative 1 plus 1. So we have 1 plus 1 is 2. So we have a negative 1, comma, 2. Go over here to graph it. Left 1, up 2. All right, next thing they want us to plug in is a 0. So the absolute value of 0 is 0, and 0 plus 1 is 1. So we end up with 0, comma, 1. So 0, don't go left or right, but we're going to go up 1. All right, blue here. So the next number they want us to plug in is a 1. So the absolute value of 1 plus 1, so we have 1 plus 1 is 2. Look at that number started repeating again in my chart. So I have 1, comma, 2 over 1 and up 2. Well, look at that. I'm getting a V again. And then the last number that they want us to plug in is a 2. The absolute value of 2 is 2 plus 1 is 3. So I end up with the ordered pair 2, comma, 3. And if you look, this makes a V, and what did this V do? It's still up 1 over 1, up 1 over 1. That width is staying the same. The whole graph is opening up, and we look at that vertex. It's not at 0, 0 like it was. It is a plus 1. It went up 1. Well, let's see now in the next view if we can skip making this T-chart and plugging all that in, if we can just use what's happening here and adjust and think what happens. So what do you think happens when you have that plus 2? See this last example, when we had a plus 1, the vertex went up 1 unit. So now if it's going to be a plus 2, it's going to go up 2. And here's your vertex. Now look in front. Do you have a number written here? No, nothing's written here. So we assume that to be the number 1. And with that number being 1, that means we're going to go up 1 over 1. And remember, it's absolute value, so we're going to go in the other direction too. And why is this opening up? Because this number right here is a positive, and that's all you have to do. So we look at this number outside, and that is making a vertical translation. So this is a vertical translation because it went up and down. And when this is a positive number, it goes up. Okay, let's try the next one. All right, looks like we still have a number 1 in front. We have a negative 3 on the outside. So what's going to happen when we have that negative 3? That negative 3, instead of that vertex staying right here at 0, 0, it's going to go down 1, 2, 3. So your vertex is going to be here. Now look at the number in front of X. There isn't anything there, so it's like having a 1. So we go up 1 over 1. And we say that this had a vertical translation, so it's vertical because all it did was go down 3. The vertex went down 3. So that's a vertical translation of down 3 or a negative 3. Why is this V opening up? Because this number in front here is positive. So basically what's going to happen today is all of your graphs are going to either go up or down. If it's a plus number, it's going to go up. If it's a negative number out here, it's going to go down. See how the numbers are outside of that absolute value. Right, the last thing they're going to ask you is if this V is going to open up or down. See how we have this negative in here? So when we put in here and you take the absolute value of negative 2, so like this first number, plugging in a negative 2, we get out a 2, but then we have this negative in front, so it's a negative 2. So we go negative 2, negative 2. So this ordered pair is negative 2, negative 2. For the next one, if we're going to put in the negatives out in front, the absolute value of negative 1 is 1, but then we have this negative out in front. So this absolute value comes out to be 1, but then you have the negative out in front. So it is negative 1, negative 1, negative 1, negative 1. Well, now if you plug a 0 in here, the absolute value of 0 is 0, so it's going to be right here at the origin. Now plug in a 1. If you plug a 1 in here, the absolute value of 1 is 1, and then you have this line out in front, so it's going to be a negative 1. And the same thing's going to happen if you plug in a 2. We have the negative out in front, so it's going to be a negative 2. So do you see how this has the origin? It's still, there's no number outside, so that vertex is at 0, 0. There's a 1 here, or a negative 1, so it's down 1 over 1. And do you see how this V is opening down because we have this number on the outside? All right, homework for today is in your Schoology homework quiz, Graphing Absolute Value, Day 1.